don't want to print these things in just whatever order I happen to insert them into the array. I first want to sort the array, and then I want to print out the sorted array. So there are a couple ways we can do that. I inserted them in the order RJ, Chris, Rob, David. So here, by looking at the NS mutable array documentation, I see that it has a whole bunch of different ways of actually sorting things. One way is this sorted array using selector syntax or method. First, let's look at student.h and student.m. So inside of student.h, I've defined a new method called compare. It's returning this NS comparison result, and the only reason that's relevant is because this sorted array using selector method expects a method to be passed to it that returns an NS comparator result, whatever it is. So this compare method is going to take another student and just compare our current student, with that student. Looking at the implementation of that, I decided that I'm just going to compare by name. So I'm going to use self.name references the NS string that is my name. And then I'm going to compare that, like the NS strings compare method, I'm going to use that to compare to the other student's name. And because this compare method returns an NS comparison result, that is an easy way of making sure that I return an NS comparison result. Okay, so now that I've defined this method for students, I'm now going to say here that I'm going to sort the students array using the selector compare. So this special syntax at selector, remember that methods and selectors are kind of like interchangeable words almost. So I can't just say like this, because that's not really a valid syntax. I want to say that I want to use the method compare colon. And so to actually specify the method compare colon, I wrap it in this special selector keyword. And so what this sorted array using selector method is going to do is iterate over this students array, calling the compare method of each student to say like, okay, student 0 and student 1, how do you compare to each other? And then like depending on how they compare, it's going to determine whether student 0 belongs in front of or after student 1. So compare has to exist for everything in this students array. And then let's just run it to make sure that's the case, that this works. So we see it prints Chris, David, RJ, Rob, which is what we wanted.
So the compare function is like preset, like to how do you compare different strings?
So how do you in here? If we could also decide that we just want to compare ages. This isn't quite right because they're ints, and I'm not sure of what NS comparison result looks like. It might just be like return self.age less than other student.age, or I guess maybe like if 1 is less than, I'm supposed to return 1, or if they're equal, I return 0, or else -1. I'm not sure what NS comparison result is supposed to look like. Actually, so another, let's go to here again. So a useful syntax that we've already seen this useful shorthand for defining an NS string, this blah, 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 with the @ sign in front of double quotes. Another useful syntax is an @ sign in front of brackets for shorthand for defining arrays. So, and NS arrays. So now I've defined an array, an NS array with 2 objects, hello and world, 2 NS strings. An additional shorthand that's somewhat useful is @ in front of any number. So this defines like NS string was the first one, NS array was the second one. This defines an NS number with the value 42. And so what may or may not work, what I'm going to try right here, no, actually that won't work at all. So I might be able to do init NS number alloc. I just want to see if this ends up working at this point. Init with int self.age. Oops. And then I want to compare that. Does it have a compare method? Compare to another NS number, which would be NS number alloc init with int other student age. Okay, so questions on what I just did there? Yes?
You didn't use the selector on the compare.
So I'm not using, here I'm just defining the compare method. It's when I want to actually reference the compare method that in here I say the method I want to use is compare colon. And this is again why I said before, like the literal name of the thing includes the colon. So here I'm referencing the method compare colon. In the definition of it, I don't need to use @selector.
But whenever you want to pass a function to a function, you have to use @selector.
A method to a method, yeah. Because if it were a function, I wouldn't need to use @selector. I could literally just use a function pointer, but you don't need to deal with those here. There's probably some spacing error here. Oh, but that's because I don't need this. Whatever. That's the general idea. So that's that. Questions before I move on to a similar idea? Yeah. And just as, remember, it's like C where this, in order to get the prototype for this thing, I can literally just like copy this, paste it, and put a semicolon at the end. So the prototype is just the first line of the definition of the function. Okay, so that's that. And now going to students 9 is where we're going to get into categories, which that's not very helpful. So here, okay, so the idea behind categories is notice that in order to do what I just did, I needed to actively modify the student class, which is fine because I'm the one who created the student class, so it's fine for me to go into the student class and add a compare method. But what if this class that I need to modify is not something I have access to? What if it's in some compiled library, or it's one of the foundation classes or an iOS class? I need to add a method to it, but I don't have access to the source code. So these are what categories are for. They're for extending existing classes. And so in Xcode, you can actually do this like file, new, file, and then category, and it'll like walk through the steps. And the default format of these categories, so remember I'm working under the assumption that I don't have access to the student class. So the default format of these file names are student, which is the class that I am extending, plus, and what I happen to call the category. So here, I am extending the student class with the category student compare. And this is just a syntax that you're free to look up whenever you happen to need to extend a class like this. So this extension of the student class is going to include this method. A category is not able to define instance variables. It's only able to define new methods for a class. So looking at the implementation of this category, again, the category itself is student compare, and I'm extending student, and I'm implementing it basically how I implemented it before, exactly the same, except I'm able to do this without ever touching the original student.h and student.m. And this will work exactly the same. Now in main.m, Instead of importing student.h, I import student plus student compare.h, because student compare.h is what is importing student.h. And everything else in here is the same. Yes? Oh, main, okay. Oh, these angled brackets and quotes. So